All right, welcome, or thank you for giving me this opportunity, buddy. Again, my name is Josh Bates. I work for NiSource, and I'm going to talk today about our Precision GPS technology program. So what does that mean? Basically, this is just an endeavor for our company, NiSource, to begin collecting high-accuracy GPS information for all of our pipeline facilities. So I'm going to talk a little bit about sort of the background about how we got to needing this, what we've achieved so far, and where we're headed with it. So first of all, a little bit about NiSource. When I talk about NiSource, it's a Fortune 500 company that has sort of an umbrella organization for a lot of companies in the energy industry. But today I'm talking about NiSource Gas Distribution, which is a gas distribution company over 6 different states. Here's a little bit about our footprint. So a pretty large area, and so we're talking about pipeline facilities that go from transmission line to the customer service meter. We also have transmission, storage, and electrical side to our business, but today this is what we're talking about. So first I'll talk about a little bit on the sort of the background about how our company got to this place of wanting a precision GPS program. So some of the industry trends, the last couple of years there have been a number of high-profile natural gas explosions incidents that have put a renewed focus on pipeline safety with the public, with regulators, with operators. Worth pointing out at this point that none of these involve NiSource gas distribution, but just to say that the natural gas has been in the news a lot lately, and that's put a lot of more resources into the integrity management side of the business. San Bruno, California, probably being one of the most well-known of those. There are also some trends within our company, NiSource, one of which would be basically factory material recalls. So, quick example, a few years ago, we had a 1-inch plastic service line, basically a batch of 1-inch plastic service lines were found out by our people to be defective after they'd already begun to be installed. And basically there was just like one batch of these pipeline that had a problem with its wall thickness. Basically, if you looked at the cross section, it was sort of the internal diameter was thin on one side, like kind of shaped like an egg. So we know where we installed all that service line, so we can go back and inspect it, replace it if needed. But just that activity cost millions of dollars, whereas just replacing, if we knew exactly where that batch of bad materials that was purchased from a vendor, if we knew where those materials were, it would cost tens of thousands of dollars instead of millions. And another factor is large-scale infrastructure investments, capital investments that we've been making and have projected for the next 10, 20 years. So basically a lot of pipe going in the ground for our footprint, replacement projects, bare steel, cast iron being replaced. And so while that pipe is going in the ground, it's a good time to collect high-accuracy GPS information about it. So that's just some of the background about how our business got to this place. And basically we had, in our group, sort of a business decision or our mandate to say we need to capture decimeter level GPS coordinates for our facilities as they're going in the ground. So that would be 10 centimeters, which is about 4 inches, or about the size of a coffee can lid. So with that, we launched a few proof of concept pilots, basically exploring different technologies that were out there. And long story short, what we came up with was, what we selected as our platform is the Trimble survey grade R10 antenna, which is also set up over here, which uses the C3 data collector, the handheld computer, and also utilizes the optimal ranging SPAR 300 accessory, which I don't have set up here, but which is the locator accessory that puts on the bottom of the pole here. So that spar uses electromagnetic locating technology with the two antennas on either end of the spar there. And it detects a energized facility, underground facility, tracer wire directly on the facility, and triangulates a location, an offset to that signal, and then leverages the survey grade R10 GPS capability to provide a GPS coordinates for that underground facility. It doesn't need to be exposed or doesn't need to be dug up, and we can still map it. So in that sense, we kind of see this as like an intersection of two advancing technologies that we use a lot with our company, which would be the mapping side, GIS, GPS, as well as a utility locating side. So I guess the latest and greatest with utility locating that we use a lot, or I guess I shouldn't say latest and greatest, but the bulk of the locating technology that we use is electromagnetic locating, which is kind of like the flower of 1970s technology. We have newer things coming out like the marker balls, RFID technology with marker tape. But this spar and this setup here utilizes both. So we view this as a multi-year journey to basically kind of play in the long game. We have facilities going to the ground. We want to capture as much information about them as possible using the sort of the most advanced technology that we can afford. And it might take a long time before we get full payoff for that strategy. So in that sense, we're kind of playing the long game. We have a rollout strategy covering all of our states, 6 different states that goes into a couple of years into the future. So our GPS collection, we consider having 3 flavors: construction, legacy, and operations. Construction being the kind of the full suite of the technology. So we're setting up our GPS directly on the facilities as they're being installed. We're getting RTK survey grade GPS coordinates for those. And we're also getting full attribution along with using barcoding to get a lot of attributes, a lot of information about the facility. So currently, what we map for our records in GIS and in our work management system, we're really capturing like 2, 3, 4 pieces of information about each facility. So a fitting, we might know what type of fitting it is, what the material is, what the size is. Pipe, same thing. We'll know what year it was installed because we know when the mapping is done. But with this GPS and the barcoding sort of suite of technologies, where it's kind of a quantum leap in the amount of information, the number of attributes that we're collecting about each facility. So we're collecting information about when the pipe was manufactured, the wall thickness, the SDR, who was performing the work, who was doing fusions, who was doing welds, and the dates that those took place. So that way, if we find that there's OQ issues with certain installers, and we said, oh, this person wasn't trained properly, we need to go back and check all of the places where they performed the fusion, we, in theory, would be able to do that. So that's the construction side. Then we have legacy, what we're calling legacy, which is basically just mapping the existing pipelines. So that would be using the SPAR, sending contractor crews out and canvassing our footprint and mapping as much as possible. So that obviously doesn't enable us to capture a lot of attributes, because this is using the SPAR, getting places where we have good tone, we can locate our facilities well, we're going to get GPS coordinates for those, but we don't really, other than that, based on our record, we can look at our records to see what's under there, but we're not capturing near as many attributes as well. Construction. Operations side would be kind of a hybrid of those two, meaning that any places where operations O&M crews are exposing our facilities, digging up pipe, fixing leaks, making repairs, they can get GPS coordinates on those and also some attributes. So I have some information here about some of our pilots that we performed, and we performed several pilots. We're also in full production mode here on the legacy side as of just of this month. So we got a lot of good information to come in with the pilots. One thing is that we also consider this as an exercise in flushing out potential inaccuracies or enhancing our GIS records at the same time. So in this case, in this example, the blue dots are GPS points that were captured using the SPAR and the R10. And the other facilities, this green line here and the dotted line, that would be the street center line and the gas main that's in our current GIS system. So we operate on a relative accuracy standard with our GIS. We know that it's not going to be always spatially accurate, especially in situations like this, this type of development for various reasons. We say, okay, we know that our GIS is not going to be spatially accurate. No one's using it with GPS in coordination with GPS coordinates or anything. But we do expect it to be relatively accurate. So is the pipeline on the right side of the road? How far is it from the center line? How far is it from other buildings? We want to have those records accurate. But if this was an example where it looked like on this Townsbury Trace, the gas main is running on the northwest side of the street in our GIS, and then when the GPS survey came back, we're getting GPS SPAR points on the southeast side of it. So this kind of thing, this is what we're finding. Most of the time, everything's good, but we're finding situations like this, and they're helping to trigger records investigations for our GIS. So it's not to say that, oh, well, we got some blue dots here. Okay, I'm going to move my GIS to line up perfectly with that. This would just be, in most cases, a trigger for further investigation, and then to make a conflation. It's in a way that this whole project is kind of like an 811 one-call ticket for our entire footprint. So here's another quick example. 4-inch steel line here running along the side of the road here, going nice and straight. And then our GPS survey comes back with these blue dots, and the blue is indicating have the maximum quality attributes, because a range of quality attributes are returned by both the R10 and the SPAR to say how accurate was this point. So it looked like there was basically a 10-foot offset that was put in it at some time over the last 30, 40, 50 years since this pipe was installed. There was some probably O&M work that got done to shift this pipe over. It looked like there was a culvert, some sort of drainage a ditch here, so probably we had to move the pipe, and that never got into our GIS record, so that's something that we can visit. Here was another example of a gas main, or some things mapped in our GIS that look absolutely accurate, meaning our street center lines are running well, on our land base are lining up well with this ortho image. This is a section of I-295 in Virginia, so interstate highway. But then we have a 4-inch gas main, 4-inch plastic gas main running into like a median strip of the interstate. So seems like an unlikely place for that to actually be. Our GPS survey comes back showing it running along the service road, which seems a lot more of a better place for that pipe to lay. So again, more examples of just like flushing out possible inaccuracies in our system. Here's another quick example of what we call like a massive inaccuracy, meaning we know that when this GPS survey comes back, our pipe might be spatially inaccurate in our current GIS. But if it gets to be beyond 250 feet, then it becomes a 811 issue. It might be outside of that 811 call buffer, so this would be a case where we would perform a conflation. So this is just a case where we had GPS points collected here going to a town border station, and then our GIS was showing it down the road here. So, yeah, some more, I could go on and on with these examples, but a little bit about data integration. So how we get this GPS information into our GIS. nightly, or sorry, at the end of the day, the Trimble job files, the JOB files, or the JXL files, the Trimble job XML files are automatically uploaded to the Trimble connected community. They can be prompted to upload to the cloud, or they can be automatically uploaded through what's called the Trimble Access Sync. So that goes to the Trimble Connected Community Cloud Server. Then we have a custom FME script that pulls the JXL file, which is the job XML format version of that same Trimble file, through, it's basically like a data pipeline, performs some different conversions and parsing, and puts it in two different places. The raw files go to our work management system, and the processed files through ETL land in a pre-production GIS database as we. So that's when our QA/QC would begin, and that data would get ingested into our GIS. So a little bit about the job XML. This is the JXL, the Trimble job XML format. It's much larger than the job files in terms of the file size, but we like it because it's an XML format. It's a little bit easier to parse, to read, and to parse out with FME. And it also represents basically like a log of everything that was done with the data collector in that day. So it's not just, okay, I'm going to export this and then out to a table, or it's a shapefile with points and lines and attributes as we define them. It's more like a log, so it has everything that was done. It has tons of metadata about the collector, the conditions of how that survey was going, what data dictionary was being used, what the different template settings on the collector and all that kind of stuff. So we can always go back, even if we are setting up our data dictionaries and our ETL to get this stuff into our GIS schema. If we set it up exactly how we like it, we put a ton of work into making sure all the fields map to the right places, all the features go to the right feature classes, and then we decide 2 years from now, you know what, it really would have been nice to have that Earth-centered, Earth-fixed coordinates or something like that. We can always go back to these JXL files and in theory, dig that information back up. So a little bit more of the details about the data and the collection. The feature data library, which is stored as an FXL file, is like the data dictionary. So this is how the data collector is set up to say what features are what are we collecting. There's just a little bit of, just the start of the list of the feature codes, which would be corresponding to like a feature type or feature class. We have more than 70 of those defined, and most of those are based on the ASTM F2897 standard. So that corresponds to the way that the barcode information that's printed on the facility. So all of the material types that are used with that standard, you should be able to pick them up with this data dictionary. Each one of the feature types has its own attributes defined, or is this a required field, or is this a numeric text field, things like that. So a lot of mapping goes on with that. That's just, we love to look at spreadsheets on slides, right? But this basically just gives you an idea of how different feature codes in the FXL, the data dictionary, get mapped to different feature classes in our GIS schema. A little bit about how those feature codes get collected. These are some shots from our quick reference guide, which is like a little laminated card book that goes with the collection. So, this is how you enter in, the collectors are entering different feature codes, and they have some cheat sheets and stuff like that. A little bit about how the coding takes place, how the features are collected. So B pipe would be buried pipe. So that would be like the feature code that the user would enter in, and then that would prompt them to enter in a number of different attributes if they know them, required attributes. We also use these line control codes, which is the Trimble General Survey way of basically drawing a line in the field. So it's kind of like digitizing. You start off, your start click point would be the plus. You have bpipe plus, and then each one of those codes that doesn't have a plus or a minus would be like your vertex along the line. And then when you're ready to finish your line and hit F2 or double click or whatever, that would be putting your minus, there to end the line. So any attributes that are common to that line will be associated and kicked out as a line feature, and then attributes that are specific to a point would be a point feature. We also have, have something called challenge point. We have a lot of different feature types, but one of which is challenge point, which is just like a sort of a feedback mechanism from field to office to say, hey, I came to an area I couldn't complete my collection. There were trees or bad tracer wire or something. I could put in a challenge point and specify why that was the case. So a little bit about data collection standards. Again, we're looking for data that's under decimeter accuracy. So, and we have a lot of other specifications on GPS quality metrics that we're looking to meet with this data collection effort. So that's probably enough for now. It's really just scraping the surface of what we could talk about with this project. But I think I like to say that it represents, for our company, the gas distribution industry, gas distribution company, heavily regulated. I think our industry tends to be fairly conservative, not always the early adopters of technology, but I think this represents a case where trying to get ahead of some of the trends and be a little bit proactive about collecting information that really, like I said before, is kind of the long game, right? We collect our GPS coordinates. It's difficult, it's complex, it's expensive, but really the alternatives are to use our traditional methods of locating, for example, traditional methods of record keeping, which have a lot of problems themselves. So tracer wire is great. It begins to break down the minute it's put in. We have a lot of cases of ownership of facilities. So, this used to be a customer, now we own line, now we own it. This used to be owned by another company. We don't know how that tracer wire was installed. We don't know if it's connected properly. There's excavators that dig it up. Marker balls are great, but excavators pull them out of the ground and throw them in the trash. So if we can collect this GPS information, like I said, at great complexity, at great cost, really it's an elegant solution because GPS at the least is just two pieces of information, right? The coordinate is just an X and a Y and a Z. So as long as we can maintain those two pieces of information, that will be good next year, 10 years, 100 years from now, that'll still be good. Whereas all those other methods would have most likely gone by the wayside. Because GPS itself, GNSS, has its issues as well, but if that's not working, we probably have bigger problems. Okay, well, thanks a lot for the opportunity to talk about this. I guess we have some time for questions.
What was when the field survey is being conducted, what's the mix of in-house personnel versus contractors or consultants you're doing work?
The legacy portion, that middle flavor, using the SPAR, is 100% contracted. We have internal staff that are GPS support team, and they are supposed to be providing just training and support, stuff like that. For the construction side, it's most likely to be more than 50% contractor because a lot of the construction work is contracted. So we're looking to just basically blend that work into the construction contracts. You already given them millions of dollars to put the pipe in the ground. Now also get this GPS information. But some of that will be done by company crews. And then that last group that was the operations piece would be 100% company staff.
And the sourcing for the aerial photography and vintage of it?
Oh, that was ESRI.
Oh, okay.
Just basement.
Okay. So does NiSource do any of their own aerial photography? You have a contract together? No. Okay. So it's all just based off?
Yeah, publicly. Right, yeah. And, I mean, looking at that, that's more used as a reference, not as a final source of QA/QC. Yes?
Hey Josh, are there any opportunities for doing things with your work order processing systems after you get all your GPS coordinates in? You guys thought about, some of the work order systems and things that might tie in there? Is that part of the reason why you're doing this?
No, it's really kind of an add-on. It does integrate with some of our work management systems a little bit, but it's really an add-on to the mapping procedure that we have. So whereas we used to map in a certain way, new facilities, putting them into our GIS, like I said, with kind of a minimal attributes, what was on a sketch. Now this is going to be pumping the GIS full of a lot more stuff. That's most of it.
So updating, after you go out and you do all your GPS, you got crews out there doing, like you were saying in your one example where you had a pipe moved out of the right of way for, probably road widening or something.
Right.
How do you plan on recapturing those afterwards?
Yeah, well, we have an internal team that would be performing that kind of, I guess, QA/QC and, updating of our GIS.
As the pipe goes in the ground and for those reworks.
Right, yeah, for all those cases.
Thanks.
Yes, sir.
Are you hoping to have like 100% of your pipeline done at some point, some long-term vision to have everything?
Yeah, I can't look that far ahead. I mean, maybe someone does, but we're just getting kicked off with the legacy mapping, as you said, this month. So, and it's hard to predict how quickly that will go. And it's also, there's a lot of factors that go into it, because we can't, if this was a transmission line going through the countryside, we could say, let's get 100% of the transmission line at a certain spec. We're expecting this to be more of a little more patchy, to say, okay, we can't locate this area. No matter how hard you try, you're not going to get any GPS points. So just move on. So I guess the answer to the question. Yes, ma'am.
You mentioned decimeter accuracy, but you guys chose survey grade, which is typically sub-centimeter. What was the main reason for that?
I guess the reason was just to try and go after to at this phase, build the highest possible accuracy infrastructure. That was the decision.
I noticed you had barcodes in the construction phase.
Yeah.
Are you utilizing that more? I know the data collector take photos and
Right.
I don't know, you process information through that or.
Right. The integration of the actual barcode scanner is not released yet with our solution. So the pilots that we did, they didn't use the barcode scanner. They entered the barcode in. So we have our data dictionary and our schema set up to allow the barcode's whole concept to work, but the hardware isn't there yet. And there's a lot that goes into that, because the manufacturer has to have it printed on there, right? And then during construction, it has to be visible and all this kind of stuff, exactly. So that's kind of the blue sky, is everything. Oh, I'm just walking along the trench and just scanning things, and it pops in there perfectly. But that probably is not going to happen a lot. There's going to be a lot of manual input. Yes, sir.
Do you guys have a separate database then of the materials that say match up with the barcodes, or do the barcodes kind of tell you what materials?
Right, yeah, the barcode within the number, the 16-digit, I think, hexadecimal number, the information is in there.
Okay.
So our FME script basically can read that and put everything in the right place. Yes, sir.
Are you going to be relying on third-party base stations? You plan on setting your own or virtual?
Oh, it's virtual.
Virtual.
Yeah, so it uses VRS. So,
Is it
yeah, sorry, I
provided
didn't
by
mention
Is
that.
it a Trimble provided service?
It's other service. So KeyNet is the service that we use in this area. And ODOT in Ohio is a free